Welcome everybody to this, the first large systems stream session of this year's TSC UK conference. Today we've got Matthias Banger. Thanks for agreeing to come back, Matthias, from our IBM Z worldwide sales team, taking us through customer experience and exploitation of TFP for hardware and software. Do you want to skip it forward one, Matthias, so I can just talk very quickly?
Yep.
So yeah, please don't forget our two charities this year, Lifeboats and Guide Dogs. Details up on the screen there in how you can donate. Please dig deep, both very worthwhile causes. So with that, Matthias, over to you, sir.
Thank you very much, Joe, and good morning, everybody. And thanks for listening to this 50-minute presentation. So we thought it makes most sense that I go through my slides, the story I have to tell. And whenever you have questions, please type them in the chat and we will answer all questions, or as many as we can, at the end of this presentation. So, as Joe said, my name is Matthias Bangert. I worked the last 22 years for IBM. So if you see the picture, you will recognize I have a life before IBM, working for clients and also a hardware competitor. In these days, I focus a lot on tailored fit pricing from the software side and also from the hardware side, but always from a technical point of view, not finances. That's we have specialized people who are called sales to care about those. So what is the agenda for today? I have 4.5 points. So first of all, I want to do a short preview, a review of tailored fit pricing for software, just that we are all on the same page. I want to explain the hardware tailored fit pricing we have announced last year. And I also want to go through some situations to think about when considering hardware and software TFP. I will take you through a couple of client situations with client data to show really what the analysis of these cases shows, and I have a little summary at the end. Now let's get started with the review of tailored fit pricing for software. So on the left-hand side, you see this graph where all the workload has the same level. Here it is like 400 MSUs. And of course, if you are charged on a rolling 4-hour average basis, you hate peaks because they increase your cost. So you want to distribute your workload, if possible, as even as you can, 24 hours a day, a whole month, so that your cost is going down. Because, as I said, you're charged on peaks. Now, that's the massive change which comes in with tailored fit pricing. You're no longer charged on peaks. We are charging the consumption of MSUs, not the peak workload. And that now means it's regardless if you're on the left-hand side of this picture or the right-hand side with the 1,000 units of work, the cost is exactly the same from a tailored fit pricing point of view. And you see you have spikes in there, you have all kinds of workload distributions, it does not increase your cost. And I mean, we have to admit, right, 4-hour rolling average is a pricing model which is more than 20 years old. And it was built in times where a machine had, I don't know, 1,000 MIPS, something like this, maybe a little more. And you had 1 LPAR or 2 LPARs on this box, but not more. And I think it was never designed for clients with 80 LPARs on the box, even 20 LPARs on one machine, which makes it overly complex to determine what's the price for an additional workload ending up on one of these 20 LPARs, right? That's completely different with tailored fit pricing for software. Now, here you see the change. Formerly, we charged on the peak, the blue line, and now the blue line is the consumption, right? And that, of course, as you can imagine, brings with it a lot of changes on how your workload is seen, right? In former times, for example, many clients just focused on this 4 hours a month where the peak was determined. Even if you wanted to save on software money, right, you looked in detail on these 4 hours and tried to optimize whatever you could, and the rest of the a month, you said, well, whatever runs on this box, I don't care because it's below my 4-hour rolling average. That's completely different in a consumption-based environment. Here you care about every single MSU you consume, regardless of time of day in the month, of product, right? Whatever you can save helps you to reduce cost. So for the tailored fit pricing for software, it's not only the MLC software, it's also the IPLA entitlements, which we convert into consumption-based pricing. Right? There is a special formula. Our sales folks will guide you through this. The important point is you do not end up with a mix of, hey, I can only run this and this high because I have IPLA products licensed to a certain limit. You can run whatever you like, consumption, whatever peaks you have, and it will be converted into consumption also, right? Now, one example of a Spanish bank we worked with in the early days of tailored fit pricing for software is, as you see here, formerly they had their online workloads, and of course these are the most critical ones. You want to serve your clients which run online transactions, and for batch you put in capping so that it does not use the full machine. And oftentimes the size of the capping, the amount of capping is determined by the online workload, and you set it accordingly for your batch workloads. But as I said before, you want to have an even distribution. So what we see in these days is a separation between online workloads during daytime and batch workloads in the night. And that brings issues with it. For example, if you max out your capacity and it's all online workload, what workload are you slowing down to have all the workload running? If you have a mix of batch workload and online workload, it's so much easier to tell batch, hey, wait a second, right? I have online workload coming in. You better run a little slower and wait a little more. And I serve the online workloads, right? If you have only online workloads, peaks will harm your response times and your business, which is at the end a bad thing. On the right-hand side, you see how that changed, right? Now the client said, well, I can run a lot more batch workload in parallel to my online workload, which makes it much easier to serve the online workloads because there is additional capacity in the system. And one side effect was they said, well, I can run the batch with all my employees in the office, or at least sitting in the home office and watching what is running, right? It's not unattended. So whenever a problem comes up, I can give the guy a ring and say, hey, your program produces an error. Can you please take a deeper look into it, right? That's not possible if you run it all unattended during the night. So I think this tailored fit pricing for software is out there quite a while. So people understand how to manage it, how to deal with it. It's not really complicated. From a pricing point of view, just to mention this, we would create a baseline, which is equivalent to the cost you pay today in your rolling 4-hour average. And we build an average over 12 months. So, you know, that it's not the last month peaks or something like this. That's the baseline, and everything above this goes for a nice discount, right? But it's the concept is a baseline and everything above the baseline. That's the basic pricing concept for TFP software. Now, if we look now at the next evolution, let's say, I mean, clients did ask us and said, well, look, TFP for software, that's a good start, but what about your hardware? On-off capacity on demand is, first of all, slow, because you know, I have to hit the button, I have to open up the machine. That all takes extra action. And as we know, right, the longest in this extra process is the decision process, when to add this capacity. And mostly it's too late, right? You know, people see workload is coming and machines get more busy, and already the response times are slowed down. And then somebody says, we can't survive, we need to add capacity. And the first users are already suffering, and the red phone is maybe ringing already. It's not comfortable. It's not a good situation. So therefore, we needed something better than that. And clients were requesting this. Now, what we introduced is tailored fit pricing for hardware. And it was especially designed to answer these demands on spikes, right? So what we saw with clients is more and more workload has a spiky character, right? And is not as linear as it was before. And oftentimes, I mean, if you want to react to these spikes, as you see in this chart here, there's no time, right, to really analyze, oh yeah, there's more workload coming, and oh yeah, I add OOCOD because it will help save me on the response times. There's no chance. You either have the capacity already there or you suffer, right? And we don't like that clients are suffering from not enough capacity. So we thought about alternatives, what we can do. And what we came up with is a model where the client says, I have a base capacity, let's say 10,000 MIPS. And as you see in blue on the right-hand side of the chart, we add a TFP hardware capacity. It's a corridor of additional hardware we add, and which is always on, right? We do not switch it on. If we see workload coming, it's always there. And it can be some percentages of the workload which you already have, the base capacity, that needs to be analyzed, which makes most sense for your specific setup, right? The price for this is split into two parts. First of all, there is a subscription fee for this always on capacity. And then there is a very cloud-like usage charge at a granularity of 1 hour. And that is based on actual MSU usage measured, not full engine capacity. It's really the MSUs you are above your base capacity. That is what gets charged, right? And I will explain this in more detail afterwards. Good. And of course, I mean, if you have more capacity permanently online, there's much better efficiency. There's faster transaction processing with shorter spikes and so on. And it's only available, we have to say that, on C15 and follow-on processors, only on general purpose CPs, not on CIIPs. And it's only available with tailored fit pricing software. And of course, I mean, if you think a minute about it, it doesn't make a lot of sense if you run rolling 4-hour average with such a concept, right? I mean, you know, how is your IPLA then licensed? What about your ISVs? So you would end up in a couple of minutes saying, no, doesn't work. It's not a concept which runs with the rolling 4-hour average. Now, what we are doing now for charging is the following. We always start at the top of the hour, and we look at 15-minute intervals. So what we need from your side, from client side, to look at these details is just an SCRT report with a detailed data section. This is not more than a parm in the SCRT job, and this parameter will produce the so-called I5 and especially V9 section. That is on a 15-minute interval. You get the usage data of the machine, and it's distinguished between base capacity and TFP hardware capacity. And I will show you later what we're doing with these reports. But we are creating the bill, so to say, out of this special SCRT report. And in the picture on the left, you see a usage pattern, right? The red line is your base capacity. The green line would be the total capacity of the machine. And you see your rolling 4-hour average is maybe below your purchase capacity, but the spikes go way above the installed capacity, not the installed, the purchase capacity. As I said before, there are two dimensions: subscription charge and a usage charge. Excuse me. On the usage charge, there's one more rule we put into place, and that is if you have more than 4 hours which you spike into this extra capacity, we would go and charge you a full day charge, not only on the hourly charge. So, I mean, if you want to sell hardware, then of course you want to have an eye on how much is this capacity used. It is really meant for covering spikes, not as a replacement for purchasing additional capacity. Now let us look a little bit deeper in the pricing, in the way we are pricing this. So in the middle, where the header is example of 4 hourly charges, you see we have 1 day, 1 calendar day, and you see you have 4 hours where the client is spiking into this extra capacity. And we are charging the highest in 1 hour, the highest of the 15-minute interval in 1 hour. So especially in the first, at midnight till 1 a.m. in the morning, the first interval, hourly interval, you see the yellow bar, and that is the highest. It's 18 MSUs above installed capacity. And that means you get a bill for 18 MSUs. Right? So, and then of course, everything in yellow here will be charged. That's the hourly usage. That is what gets charged in the middle of the chart. On the right-hand side of the chart, you see an example of a daily charge. Why is it daily here? Because we have more than 4 hours where you spike into the extra capacity on a single day. And that's a situation where we say, well, if it is this often, then we charge for the full day, not only for the hours where you peak into this extra capacity. Okay. There's one more topic I would like to briefly discuss with you, and that's a real client case here. And you see the rolling 4 hour average of this client is, I don't know, below the 2,500 MSUs. That's already 16 minutes. If you would average it more, the rolling 4 hour average would be about 2,000 MSUs, I would guess. Now, the more you look at shorter intervals, the more you see what workload is really in the system and what demand for workload is really there, right? And the problem here is you don't see these spikes if you look at 15-minute intervals, at 60-minute intervals, as some clients are doing. And you see even the difference between 50-minute interval and 1-minute interval is 3,400 MSUs versus 6,000 MSUs, which is the real demand. And I mean, if there is demand for 6,000 MSUs, if your machine has 3,500, right, because you think that is still 70% or it's good enough to serve my workloads, they are building queues in DB2, in COS, in CICS, in whatever subsystem you have. And these queues are a bad thing, right? So that's the last thing you want to have in your system, building queues, because this really hurts, right? So you want to reduce these queue depth, and you want to run your system more efficiently, right? Otherwise, this may become a surprise, an issue, and you, first of all, you don't know where it's coming from, but these spikes can hurt really a lot if you do not have them on your radar, right? So always keep in mind, if you average your data in 15-minute or whatever intervals, you are not looking at the real situation in your system. This is averaging out the situation already too much. You may need to look into shorter intervals to really see what's going on in your system. Now, if we look at situations where we have software and hardware TFP, it's very obvious. Not all situations are good for either software TFP or hardware TFP. There are some situations where we would say, think a little bit more about. So let's talk about these situations. First of all, I want to give you some user feedback on TFP software advantages. And what I'm hearing over and over again is that the LPAR setup for pricing is no longer necessary. Right? So this architecting systems just to fulfill the CFO's pricing and lower the cost demand was not helpful in the last many years, let's say. So the freedom of clients to design their LPARs as they like is one of the largest advantages that tailored fit pricing for software brings with it. And last week I was talking to a client in north of Germany, and they had they distinguished LPARs, and they need to, between NALC LPARs, new application license charge LPARs, and non-NALC LPARs. And I mean, that made a lot of sense to them because they saved real money with these NALC LPARs. But it doubled the amount of LPARs because they had their LPARs with both types of workload in it when they started the journey. So IBM demanded that they create new LPARs for NULC. And they immediately jumped on this and said, whoa, we can cut the number of LPARs we have on our system by half. And that means the systems run more efficient, there's less maintenance to do, and so on and so forth. So that's one of the largest improvements we have here. The next one, which I have some examples for later on, is one pricing methodology instead of many, right? And if you review SCRT reports from clients and you see they have NULC pricing, getting started pricing for WebSphere, mobile usage pricing, CCAP pricing, you know, then they need to care about sysplex aggregation and stuff. And then, you know, somebody ends up at your desk and says, can you tell me what this new application would mean cost-wise? And of course, the answer is no, because, you know, I cannot predict when the peaks are. I cannot predict when your application is running, you know, what the circumstances are. So very problematic. With tailored fit pricing for software, it's easy. You just have to calculate the amount of MSUs you burn, and you have the prices on the table for the additional MSUs, so you can give out prices very easily. And next point, workload can run independent of the time of day. We talked about this. You don't have to monitor capping any longer, because capping makes no sense in tailored fit pricing for software environments. We have clients telling us that they have higher availability due to CICS DB2 IMS running in all LPARs without additional cost. Formerly, they needed to slice down the products per LPAR to save money, no longer necessary. And now, last point, reviewing all consumed MSUs independent of applications and products you run is rewarding. So in former times, for example, nobody looked at DFHSM because it was always run outside the rolling 4-hour average window. Now it's very rewarding to look into how can I save money with DFHSM. And there is a feature called transparent cloud tiering, where just metadata gets transferred to the mainframe. And besides this, there's a direct communication between the DASD and the tape. So the COS is no longer the data mover, the disk storage does this itself. And of course, this saves real good money for clients. And now all the technology built in these products can really be helpful to reduce the monthly bill here. Now, of course, if we flip the coin now and look on the other side of this coin, then we need to admit that tailored fit pricing for software is ideal for growing clients, or at least clients with a stable workload. It's ideal if historic analysis shows higher growth for the rolling 4-hour average than for the consumed MSUs, meaning you have more workload in peak hours. Then looking at the total consumption is of course much better than looking at the peaks. You have to also to say there are no cost savings out of the box, you know, because the baseline is what you pay today. Only the MSU growth might be less costly, right? If you are in a situation where you decline because, you know, workloads are going to different countries, workloads are leaving the mainframe, and we have to admit that happens, then you need to agree with IBM a recalculation of the baseline, and you need to build this into your contract. Otherwise, you will just pay too much. And it also makes no sense if you cannot negotiate with your ISVs to change towards a tailored fit pricing model away from the rolling for our average. And we have ISVs which say, well, that's no problem with TFP, like Broadcom and I think also BMC. They made statements that they embrace this model, but there are other ISVs where it's more complicated, let's say, to negotiate this. So of course you need to have an eye on this. Mixing both pricing methodologies is, in my opinion, not a real good idea. Now, if we go to the TFP hardware side, on the positive side, we have a higher number of active processor engines have a positive N-way effect. I think this is without doubt. We have improved and more predictable response times. It's ideal for short spikes, and it can be ideal for clients who don't know their growth rates. When do you need to think a little bit more about hardware TFP? Well, situations where your batch is eating up all the machine. If you have your machine 100% full during batch times, you need to think about how to limit it. And it also does not work with products, ISVs, as I said before, which are charged on rolling for our average. So you need to solve this before going to tailored fit pricing hardware. Clients with very predictable high growth rates may run into higher usage charges. So if you know exactly where you are in 6 months from now concerning your growth, you need to look into bank MIPS, for example, or other concepts. So our recommendation is have a detailed analysis of the workload before going further, right? Review this carefully with your IBM friends or business partners, so that there are no surprises. Now, let's look into some client situations. Here you have a situation, and you always see here a full month, right? And you see a workload with very high rolling for our average. The green line is the capacity of the machine, and of course there's overhead in the machine. So now we installed one engine more, and you see that the rolling for our average went down significantly, and the spikes are of course quite a bit above the 603 level here. So here in this machine, you would say, if you purchase or if you go to tailored fit pricing hardware, in this case, your usage would be too high. So that's a situation we from IBM would say, hey, it's not clever to go for tailored fit pricing hardware. Consider adding an engine and then add a corridor for tailored fit pricing for hardware. But here it would be just wrong to say go for it straight away, right? And a detailed analysis just shows you what's possible. And the good news is we can agree on a proof of concept and can say, hey, for a month, maybe 2 months, we will add capacity for you. You try it out, what that means for you. And then we reduce it again, and we talk about the effects, we analyze it, and we see what tailored fit pricing for software and hardware would mean for your installation. So you do not buy something which you would not be able to predict the results for. So here is another client from Austria we analyzed. And in this usage pattern, that's the perfect one for tailored fit pricing for hardware. You see here that the average is really not so high, right? The average usage, even the rolling 4-hour average is at around about 1,600 MSUs and 2,000 MSUs the total machine has. But you see spikes which hit the limit of the box, and it's 15-minute intervals. So you can expect that if you look at 3-minute intervals or less, you would see that there's more demand to go above the installed capacity. And if this client would grow, I mean, there's some headroom to grow, but the spikes will more often reach the limit of the installed capacity. So therefore, in this situation, we would recommend, hey, look into the tailored fit pricing hardware in some detail, right? I'm not saying this is a must in this situation, but it's like an insurance, right? If anything bad happens, the capacity is just there, right? And here we have a client which has the hardware TFP activated. And here you see on the more left-hand side, this client was spiking above the 3,500 purchased MSU capacity. So there are a few days in the month they are spiking into this. And you will see this has an effect as we are charging the client then on the usage above the purchased capacity. And that's the report, just to show this as we will produce it to charge you the additional cost. You see the cost here is very limited. I mean, I would guess you would consider $370 really not a big bill compared to the whole mainframe bill. But it offers a real nice value, and you could spike into this corridor whenever needed, right? Serving the online workloads, especially better than before. Now, let's have a look a little bit into the software usage, TFP software usage patterns. So here you have a client which is a 100,000 MIPS client, 50,000 MIPS in SIPs, full data sharing for all applications, 10% yearly growth rates. And that was their LPAR setup before they started TFP software. One LPAR or one LPAR per machine was CICS DB2 COS. One LPAR was just DB2 and COS. And the last LPAR was just vSAM RLS and COS, no DB2. Of course, architected for pricing, not for business needs. Right? And the issues they faced were if one LPAR or machine fails, all workload ends up in milliseconds on the other machine. And just flushing the surviving DB2 and vSAM RLS systems with workload. I mean, and then you need to react and say, okay, OOCOD, now we add capacity to handle this. But even if it takes 5 minutes for OOCOD to be activated, that's way too long, right, to cover for this extreme situation then. Of course, also maintenance in weekdays was not possible, so there was room for improvement, let's say. So then they started with tailored fit pricing for software. And you can see first that they did was distributing the DB2 workload to all LPARs. That gave a little relief, right? So now if one machine fails, you have at least 3 LPARs ready who could serve DB2, and their main workload is DB2 DDF workload. And I mean, they could IPL the LPARs S3, S4, 5, and 6 during the week. However, S1 and S2, the big CICS LPARs, could not be IPL'd because it was too much risk to just run with one LPAR. So what they finally decided on was to have such a model, 4 machines equal, more or less equal workload distribution, and now having all workloads on all 4 machines, production as well as dev test. And with this setup, they're now very, very happy and can handle spikes much more easily. But the main improvement is they don't need to move LPARs anymore, right? They could just move workloads, and therefore they reduce their recovery time objective, the RTO, from minutes to seconds. Because, you know, you just need to if one LPAR goes down, you don't need to do anything. Workload distributor is moving the workload automatically to the surviving machines. You can then add additional capacity, but there will be no issue anymore, right? So, and I mean, without tailored fit pricing, there would have been no chance to go this route, because it was architected for LPAS for optimizing the pricing, and with this new setup, enabled through tailored fit pricing for software, they can run the machines and their COS workloads much better to serve their business. Now I have some fun examples. If you would look at these usage patterns, and every color is a different LPAR, of course, and you would look at this and would say, so what? Looks normal, right? So it's all good. It's not full, machine is just running, right? So no issues, that's fine. If I show you the next slide, you see for this interval before, you see the capping patterns. So very many of these LPAs got capped, and somebody would need to monitor this to see, hey, do I cap too much? Is the workload still running as expected? So that's a situation you can, of course, handle, but don't tell me that's smart, right? That is not smart. That's compared to a tailored fit pricing solution where you just get rid of capping. This is not a smart solution. I worked with another client in Germany, and I showed him this picture you see here, right? Which is for the month of December 2020. We looked at the days from the 1st of December to the 31st. And I just had the SCRT report. There are 2 machines. The one is in blue, the other one is in green. And I just put in this chart the 4-hour rolling average peak of this product, because as you know, this concept of rolling 4-hour average is per product. So 2 different machines, completely different setup, no full Sysplex implementation. And as you see, we have, I don't know how many, 1, 2, 3, 4, 5, 6, 7, 8, 9 different days with peaks. And I told this client, hey, could you maybe consider going for tailored fit pricing? And his answer was, no, everything is running fine. I have everything under control. Well, the client is king, right? So what can you say? I don't think that you can control 9 different peaks of, I don't know how many products in a month on 2 different machines not running in a full data sharing Sysplex. I think there was much more wishful thinking than really controlling what is happening on these machines. And with tailored fit pricing for software, there would be no peaks anymore. You have consumption for these products, right? And you just let it run. You let peaks occur because you know they don't harm anymore, right? So, but if you want to sit every day and monitor which product has the next peak, right, and at what time of day it has it, good luck, I have to say, good luck. Now, let us summarize the situations a little bit. And first of all, let's start with the tailored fit pricing software assessment. So I had like 12 points I would recommend you look at once going for tailored fit pricing for software. It starts with the amount of capped LPAs, the length of capping, and the effort to control capping. Then the business impact due to inflexible workload distribution. There is spikiness of the workload, the growth rates you have of consumed MSUs versus rolling 4-hour average, the LPA layout, the nightly batch running too often into online hours, and don't tell me that does not happen. That happens all around the world, right? I see clients where the rolling 4-hour average in the online times have new peaks because in the morning there was still batch running. Then how to handle different pricing models, how to give prices for new workload coming in. Issues with Sysplex aggregation might be something to look at. ISV tools to separate products per LPA. If you use those, they are no longer necessary. Potential savings, which come along with compression, sort accelerators, latest compilers, DFHSM improvements, you name it, right? They now all come into play once you look into tailored fit pricing for software. SIP workload being dispatched on CPs, you might say that's okay for rolling 4-hour average outside the peak window, not okay for tailored fit pricing for software. And maybe available memory to run more workloads in parallel. These are all technical benefits. Of course, I know the sales guys will make the offering, and first of all, you look at the prices, what did I pay so far, what will be the future, and that's fully understandable. The message here is there's so much more than just the money you pay for the software bill, right? One methodology or the other. The tailored fit pricing methodology has so much benefits also on the technical side. And that translates finally serving your business better for the same cost. I think that's a deal. And finally, for tailored fit pricing for hardware, here we need to say you need to look at the usage of today's machines. And if running at the hardware limit, consider purchasing more capacity first. You need to take a look at the batch workload patterns, which need special attention. You need to look into how much additional hardware capacity is really needed to make a difference. For some clients, 10% is a good solution. Others are only happy with 30%. So therefore, it's important to look into the details first. That's my fourth point. Do a detailed analysis of your hardware usage pattern with low RMF intervals to understand the benefit. As I said before, we only offer yes, IBM tailored fit pricing hardware for tailored fit pricing software clients. It makes no sense in a rolling 4-hour average environment. So you need to review your ISV contracts. The usage charges are potentially very low. However, you can have a lot of spikes into this additional capacity, which lowers your system overhead and which can substantially, as we saw, reduce your overall software bill. If you are not sure if your workload will grow or not, tailored fit pricing hardware is a very nice option to be on the safe side, right? So for a good price, I think you're on the safe side. If your workload grows, then you're covered, right? If you see it coming and you see, yes, this is a permanent growth I have, not just for a month or two, then you can still react and purchase additional capacity, but you don't have to purchase it. And then you say, whoops, this was just a temporary action, and now I have additional capacity which I don't need the rest of the time. If you have a predictable growth year to year, right, and some clients are still in this situation, happily enough, then you need to review additional options like bank MIPS and say, well, I activate those in times of higher workloads. But if you can predict your spikes, then I would recommend you also look into additional options. With this, I'm through my presentation. I hope that was helpful for you in assessing if tailored fit pricing for software or hardware makes sense for your company. Please submit your feedback. That's very important to us. So don't miss this one. And with that, back to you, Joe. I'm done. Do we have any questions?
So if anyone has any question, they can write it in the chat box, please.
There is one in there already, really.
So there's one question,
yeah,
saying, so the limitation on TFP consumption is the capacity on the box available. For software, yes. Yes, exactly. So the limit on what you can spike to is the capacity of the box. And a capping would not work here because we are looking at 4-hour rolling averages when implementing capping, at least not the soft capping, which is implemented by WLM. That would not prevent spikes to the installed capacity of the box. Yeah.
Okay, any other questions from anyone? Well, Matthias, thank you very much for an excellent presentation. Guys, thank you for attending today's session. Our next session for the Large Systems Working Group will be at 12 p.m. today, UK time, and that's to cover what's new in ZOS version 2.5. So if there aren't any other questions, we can close this session. And thank you again, Matthias. Thank you everyone for attending. Thank you.
Thank you, Rui and Joe. Have a good day. Bye-bye.
Thanks all. Bye-bye.